Hey everyone, and welcome to this exciting deep dive into the world of AWS Cloud Computing. Are you ready to build, innovate, and scale like never before? Whether you're a seasoned IT pro, a budding developer, a cloud architect designing the future, or an AWS student just starting your journey, this comprehensive tutorial series is built just for you. We're going to explore the core of AWS, uncover its incredible potential, and equip you with practical knowledge and pro tips to navigate the cloud with confidence and enthusiasm. Let's get started on this amazing cloud adventure. So what exactly is AWS? It stands for Amazon Web Services, and it's not just a platform. It's a massive, ever-expanding ecosystem of cloud computing services provided by Amazon. Think of it as a global utility company for computing power, storage, databases, and so much more, all available over the internet. AWS offers a powerful mix of services. You get infrastructure as a service, IaaS, giving you raw computing resources like virtual servers and storage. There's platform as a service, PaaS, where AWS handles the underlying infrastructure so you can focus purely on your applications. And yes, even some packaged software as a service, SaaS offerings are part of the mix. The magic of AWS lies in its on-demand nature and pay-as-you-go pricing. Instead of buying and managing expensive hardware, you can instantly access exactly the resources you need when you need them, and only pay for what you actually use. This flexibility is revolutionary for businesses and developers alike. This model allows you to easily scale your resources up or down in minutes, not months. Need more computing power for a peak traffic event? Spin up more servers instantly. Demand drops? Scale back down and save money. This agility is a game changer for innovation and efficiency. For cloud architects, AWS provides the building blocks for designing resilient, scalable, and secure systems. For developers, it offers powerful tools and services to build and deploy applications faster than ever. IT professionals can leverage AWS to modernize infrastructure and streamline operations. And for students, it's the essential foundation for a career in cloud technology. AWS offers over 200 services, which can seem overwhelming at first, but let's focus on some of the foundational ones that you'll encounter frequently. These are your essential tools for building in the cloud. First up, compute. This is where your code runs and your applications live. AWS gives you incredible flexibility here. Amazon EC2, Elastic Compute Cloud. This is arguably the most fundamental compute service. EC2 provides resizable compute capacity in the cloud, essentially giving you virtual servers, or instances, that you can configure and manage just like physical servers. You have full control over the operating system, software, and configuration. EC2 instances come in a vast array of types, optimized for different workloads, from general purpose to compute optimized, memory optimized, accelerated computing, and storage optimized. You choose the instance type that best fits your application's needs and budget. You can launch instances from Amazon Machine Images, AMIs, which are templates containing an operating system and often pre-installed software. AWS Lambda. Now let's talk serverless. Lambda is a revolutionary compute service that lets you run your code without provisioning or managing servers. You simply upload your code, and Lambda automatically runs it in response to events, like changes in data, requests to an API endpoint, or changes in state. With Lambda, you only pay for the compute time you consume, down to the millisecond, and you don't pay when your code isn't running. This is incredibly cost-effective for event-driven architectures, microservices, and tasks that don't require a continuously running server. It's a favorite for developers looking to reduce operational overhead. Data is critical, and AWS offers robust, scalable, and durable storage options. Amazon S3, Simple Storage Service. S3 is object storage built to store and retrieve any amount of data from anywhere on the web. It's designed for 99.99% 11 nines of durability, meaning your data is incredibly safe. You store data as objects within buckets. S3 is perfect for a wide range of use cases: website hosting, data backups, disaster recovery, archiving, big data analytics, and content distribution. It offers different storage classes, like standard, intelligent tiering, standard IA, one zone IA, Glacier, Glacier Deep Archive, allowing you to optimize costs based on how frequently you access your data. Amazon Glacier. While technically a storage class within S3 now, Glacier is specifically designed for long-term archiving and backup. It offers extremely low-cost storage, but with retrieval times that can range from minutes to hours. It's ideal for data you rarely need to access but must retain for compliance or historical purposes. Every application needs a database, and AWS provides managed services to make database administration much simpler. Amazon RDS, Relational Database Service. RDS makes it easy to set up, operate, and scale a relational database in the cloud. It manages common database administration tasks like patching, backups, and scaling. This frees up your time to focus on your applications. RDS supports several popular database engines, including Amazon Aurora, AWS's high-performance MySQL and PostgreSQL-compatible database, PostgreSQL, MySQL, MariaDB, Oracle, and SQL Server. You choose the engine that fits your needs, and RDS handles the heavy lifting of managing it. How do your cloud resources talk to each other and to the outside world? That's where networking comes in. Amazon VPC, Virtual Private Cloud. VPC allows you to provision a logically isolated section of the AWS cloud, where you can launch AWS resources in a virtual network that you define. You have complete control over your virtual networking environment, including selection of your own IP address range, creation of subnets, and configuration of route tables and network gateways. VPCs are fundamental for security and organization. You can define public-facing subnets for web servers and private subnets for databases, controlling traffic flow between them using security groups and network access control lists, NACLs. Understanding VPCs is crucial for designing secure and well-architected cloud environments. Beyond these core services, AWS offers a vast portfolio. AWS Identity and Access Management (IAM) is critical for securely controlling access to your AWS resources. Amazon CloudWatch provides monitoring and observability. AWS CloudFormation allows you to provision your AWS infrastructure using code, infrastructure as code. Services like Amazon SQS, Simple Queue Service, and Amazon SNS, Simple Notification Service, are vital for building decoupled, scalable applications. Amazon Route 53 is a highly available and scalable cloud domain name system, DNS web service. Exploring these and many others will unlock even more possibilities. When we talk about cloud computing, we often categorize services based on the level of management AWS provides. Understanding these models helps you choose the right service for your needs and understand your responsibilities. IaaS provides the fundamental building blocks of cloud IT. With IaaS, you get access to basic resources like computing power, virtual machines, storage, and networking components. AWS manages the underlying physical infrastructure, servers, storage hardware, data centers, but you are responsible for managing the operating system, applications, and data running on those resources. This model offers the highest level of flexibility and control over your IT infrastructure. Examples in AWS include EC2 instances, Amazon S3 as raw storage, and Amazon VPC. Cloud architects and experienced IT professionals often leverage IaaS to migrate existing applications or build highly customized environments. PaaS provides a layer of abstraction over the infrastructure. AWS manages the underlying hardware and operating system, and often the runtime environment, like a web server or database engine. You, as the developer, focus primarily on deploying and managing your applications and data. PaaS simplifies development and deployment by removing the need to manage the underlying infrastructure. Amazon RDS is a great example of PaaS for databases. AWS handles the server, OS, and database software patching, while you manage the database itself and your data. AWS Lambda is another example, where AWS manages the compute environment entirely. PaaS is excellent for developers who want to accelerate application delivery. While less central to the core infrastructure focus for architects and IT pros, it's worth noting software as a service, SaaS. Here, AWS provides a complete, ready-to-use application managed entirely by AWS, like Amazon Workspaces, virtual desktops, or Amazon QuickSight, business intelligence. You simply use the application. AWS isn't just a collection of services, it's built upon powerful features that enable its capabilities and benefits. Pay-as-you-go pricing. This is a cornerstone of cloud economics. You are charged based on your actual consumption of resources, often down to the hour, minute, or even second for compute, and per gigabyte for storage and data transfer. This eliminates large upfront capital expenses and allows you to align costs directly with usage. It's incredibly cost-efficient, especially for variable workloads. On-demand provisioning. Need a new server? You can provision it in minutes with a few clicks or an API call. This rapid provisioning allows for incredible agility. You can quickly spin up resources for testing, development, or production, and scale them down just as easily. This speed is a major advantage over traditional IT procurement. Global infrastructure. AWS boasts a vast and robust global network of data centers. This infrastructure is organized into regions and availability zones, AZs. A region is a physical location in the world where AWS has multiple, isolated, and physically separate AZs. Each AZ consists of one or more discrete data centers with redundant power, networking, and connectivity. Having multiple AZs within a region allows you to design applications that are highly available and fault-tolerant. If one AZ experiences an issue, your application can fail over to instances running in another AZ within the same region. AWS also has edge locations for services like Amazon CloudFront, Content Delivery Network, and Route 53, which cache data closer to end users, reducing latency. This global presence is crucial for delivering low-latency services worldwide and for disaster recovery strategies. Wide range of services. As we've seen, AWS offers an unparalleled breadth and depth of services across compute, storage, databases, networking, machine learning, analytics, security, and much more. This allows you to build virtually any type of application or IT solution you can imagine, using integrated services that work seamlessly together. This eliminates the need to source and integrate disparate technologies from multiple vendors. Scalability. AWS is designed for massive scalability. You can easily scale your applications up, add more resources to an existing instance, or add more instances based on demand. Services like EC2 autoscaling can automatically adjust the number of EC2 instances based on predefined metrics. Amazon RDS supports read replicas to scale database read operations. This inherent scalability means your applications can handle sudden spikes in traffic or gradual growth without performance degradation. Security. Security is a top priority for AWS and its customers. AWS provides a secure global infrastructure and offers a wide array of security services. It operates under a shared responsibility model. AWS is responsible for the security of the cloud, the underlying infrastructure, while you are responsible for security in the cloud, your data, applications, operating systems, network configuration, etc. AWS provides tools like IAM, security groups, NACLs, AWS WAF, AWS Shield, and KMS to help you meet your security responsibilities effectively. Management tools. AWS provides a comprehensive suite of tools to help you manage and monitor your cloud resources. Services like Amazon CloudWatch for monitoring performance and setting alarms, AWS CloudTrail for logging API calls and tracking activity, and AWS Systems Manager for automating operational tasks are essential for efficient cloud management. These tools provide visibility and control over your environment. Moving to or working with AWS is exciting, but it also requires new ways of thinking, especially around security and cost. Here are some essential tips and tricks to help you succeed. Security is paramount in the cloud. Don't treat it as an afterthought. Enable multi-factor authentication, MFA, for the root user. This is the absolute first step you should take after creating an AWS account. The root user has unrestricted access to all resources. Enabling MFA adds an extra layer of security, requiring a second factor, like a code from a mobile app or a hardware device, in addition to the password to log in. Protect that root account like gold and use it only for initial setup and account management tasks. Secure your account with IAM. AWS Identity and Access Management. IAM is your primary tool for controlling who can do what in your AWS account. Do not use the root user for daily tasks. Create individual IAM users for people and use IAM roles for AWS services that need to interact with other services. Apply the principle of least privilege. Grant only the permissions necessary for a user or service to perform its required tasks, and no more. Use IAM groups to manage permissions for multiple users easily. Learn to write and understand IAM policies. They are the core of access control. Follow best practices for security in the cloud. This is an ongoing effort. Regularly review your security configurations. Use security groups and network access control lists, NACLs, to control network traffic to and from your instances and subnets. Encrypt your data at rest, e.g., using S3 default encryption, EBS encryption, RDS encryption, and in transit, using TLS, SSL. Implement logging and monitoring using CloudTrail and CloudWatch to detect suspicious activity. Consider using services like Amazon GuardDuty for intelligent threat detection. Stay informed about AWS security updates and new services. One of the biggest benefits of the cloud is cost savings, but it requires active management. Don't let costs surprise you. Create a billing alarm. Set up an alarm in CloudWatch that notifies you via email or SMS if your estimated AWS charges exceed a certain threshold within a billing period. This gives you an early warning if costs are running higher than expected, allowing you to investigate and take action before the bill arrives. Make use of the free tier. AWS offers a generous free tier for many services, allowing you to experiment and run small workloads without incurring costs. This is fantastic for students and developers learning the platform. Be mindful of the free tier limits, as exceeding them will result in charges. Shut down idle EC2 RDS instances. This is a simple yet effective cost-saving measure. Development, testing, or staging environments often don't need to run 24/7. Schedule these instances to shut down during off hours, evenings, weekends, and start up again when needed. You only pay for the compute time the instance is running. Optimize your use of AWS services. Understand the different options within services. For S3, choose the appropriate storage class based on access frequency. For EC2, select the right instance type for your workload. Don't over-provision. Explore different pricing models like reserved instances and savings plans for predictable workloads, which can offer significant discounts compared to on-demand pricing. Consider using spot instances for fault-tolerant workloads that can tolerate interruptions, as they offer substantial cost savings. Monitor your resources and usage closely. Use AWS Cost Explorer to visualize your spending patterns, identify cost drivers, and forecast future costs. Set up AWS budgets to track your spending against planned amounts and receive alerts when you approach or exceed your budget. Tag your resources, e.g., by project, team, environment, to allocate costs accurately and understand where your money is being spent. Regularly review your architecture to identify areas for optimization. Use AWS Cost Explorer, AWS budgets, and AWS reserved instances or savings plans. These are your key tools for cost management. Cost Explorer gives you visibility, budgets help you control, and reserved instances or savings plans help you save on predictable usage. Learn how to leverage them effectively. Automation is key to efficiency, consistency, and speed in the cloud. Use automation to speed up deployments and tasks. Manual processes are slow, error-prone, and don't scale. Automate everything you can. Use the AWS Command Line Interface, CLI, or AWS SDKs to script interactions with AWS services. For infrastructure provisioning, embrace Infrastructure as Code, IAC, tools like AWS CloudFormation or the AWS Cloud Development Kit, CDK. These tools allow you to define your infrastructure in code, version it, and deploy it reliably and repeatedly. Consider using AWS Lambda for automating responses to events or running scheduled tasks. AWS Step Functions can help orchestrate complex workflows involving multiple AWS services. Automation reduces operational overhead, minimizes human error, and enables faster deployments and updates. AWS has learned a lot from its customers. Leverage that knowledge. Choose the right AWS service for the job. With so many services, it's crucial to select the one that best fits your specific requirements. For example, should you use EC2 or Lambda for a particular function? Should you store data in S3, EBS, or RDS? Understanding the strengths and weaknesses of different services is key to building efficient and cost-effective solutions. Determine your needs and requirements before selecting services. Don't just pick the latest or most popular service. Clearly define your application's requirements for performance, scalability, availability, durability, security, and cost before designing your architecture and selecting services. Consult the Trusted Advisor. AWS. Trusted Advisor is a fantastic free tool that provides recommendations across 5 categories: cost optimization, performance, security, fault tolerance, and service limits. Regularly check Trusted Advisor for actionable advice on improving your AWS environment. Follow the AWS Well-Architected Framework. This framework provides architectural best practices across 6 pillars: operational excellence, security, reliability, performance efficiency, cost optimization, and sustainability. It offers a structured approach to designing and operating reliable, secure, efficient, and cost-effective systems in the cloud. Use the AWS well-architected tool to review your architectures against the framework. Keep your data safe and secure. This ties back to security, but it's worth reiterating. Implement strong access controls, encrypt sensitive data, back up your data regularly, and test your restore process, and have a disaster recovery plan. Your data is one of your most valuable assets. Cloud adoption is also about people and skills. Build a team with the right technical skills. Cloud computing requires new skills. Invest in training your team on AWS services, architecture patterns, security best practices, and automation tools. Encourage continuous learning as the cloud landscape evolves rapidly. Find a good technical lead to build a solid technical foundation. A strong technical lead with cloud experience is invaluable for guiding architectural decisions, setting standards, and mentoring the team. Their expertise can prevent costly mistakes and ensure your cloud environment is built on a solid foundation. Consider working with expert cloud partners. If you're new to AWS or tackling a complex migration or project, consider partnering with an AWS Partner Network, APN, consulting partner. They have deep expertise and can accelerate your cloud journey, provide specialized skills, and help you implement best practices. Wow, we've covered a lot of ground. From the fundamentals of what AWS is and its core services like EC2, Lambda, S3, RDS, and VPC, to understanding cloud models, key features, and essential tips for security, cost optimization, and automation. This tutorial provides a solid starting point for anyone looking to understand and work with AWS. But the journey doesn't end here. The best way to learn AWS is by doing. Get hands-on with the AWS free tier. Experiment with launching EC2 instances, creating S3 buckets, and setting up a simple RDS database. Explore the AWS Management Console and try out the CLI. To deepen your knowledge and validate your skills, explore the vast resources available from AWS, including documentation, white papers, online training courses, and webinars. Consider pursuing AWS certifications. They are highly valued in the industry and provide a structured path for learning and demonstrating your expertise, whether you're aiming for an associate, professional, or specialty level. So, take what you've learned today, dive into the AWS platform, and start building. The cloud is an incredibly powerful tool, and with the right knowledge and approach, you can unlock its full potential for innovation, efficiency, and growth. Ready to take the next step? Sign up for an AWS account if you haven't already, explore the services we discussed, and start building. Don't forget to check out the AWS documentation and training resources. And hey, if you found this helpful, give us a like, subscribe for more cloud tutorials, and share your biggest AWS takeaway in the comments below. Let's build amazing things together in the cloud.